Imagine a multi-million-dollar data center powering, global logistics.
Right, something truly massive.
Exactly. We are talking about 100,000 square feet of continuous hum, just racks upon racks of servers processing financial transactions, streaming media, routing global supply chains.
And it only takes one tiny failure to threaten all of that.
Yeah, precisely. Deep in aisle 4, let's say rack 13D, a single cooling fan fails.
Ooh, that's bad.
It is. Within seconds, the ambient temperature inside that specific server chassis just, starts to spike.
And it climbs fast.
Really fast. Now, if a human being has to physically notice a blinking amber light on that rack to fix this problem, the network goes down.
Right, you're looking at millions of dollars just evaporating.
Exactly. But today, we are going on a deep dive into the exact blueprint that allows that overheating server to automatically diagnose itself, speed dial the help desk, and literally write its own medical chart in milliseconds.
It's essentially the invisible nervous system of cloud computing.
It really is.
And we are dissecting a document today that, most people will never actually see, but that everyone relying on the internet implicitly trusts.
Right.
Specifically, we're looking at the Supermicrocomputer Inc. ServiceNOW integration guide. And we're analyzing the webhook integration, release 3.12.0, version 1.1.
From July 2026, yeah. So why should you, the listener, care about a highly specific 26-page IT integration manual?
It's a fair question.
Right, because understanding this document is, it's basically understanding how massive scale IT infrastructures actually survive the chaos of continuous operation.
Yeah, without falling apart.
Exactly. We are looking at how a hardware management system called SuperCloud Composer, which we'll just refer to as SEC for short, how it communicates with ServiceNOW.
And it does this using something called a webhook.
Right. But, I want to challenge the foundational premise here right out of the gate.
Okay, let's hear it.
For legacy systems, my instinct is always to rely on, SNMP traps or just continuous polling.
Oh, the old are we there yet approach.
Yeah. If you have this massive ServiceNOW instance managing your IT operations, why not just have it constantly poll the SEC? Just, are you healthy? Are you healthy? Are you healthy? Why introduce a webhook architecture at all?
Well, so that polling architecture is actually how a lot of older enterprise environments were built.
Yeah.
And, it works perfectly fine when you have 50 servers.
Sure, 50 is easy.
But it becomes a completely catastrophic bottleneck when you have 50,000 servers.
Oh, wow. Yeah, the scale is just totally different.
Exactly. Think about it. If ServiceNOW is continuously polling the SEC appliance, it is initiating a network request, keeping a connection open, waiting for a response, and then tearing down that connection every few seconds.
Right.
Multiply that by thousands of endpoints. You are consuming just massive amounts of CPU cycles, memory, and network bandwidth on both sides.
Both the ServiceNOW side and the SEC side.
Yep. Just to establish that absolutely nothing is wrong.
Yeah.
99% of the time.
It's an incredible waste of compute just to, measure silence.
Measuring silence, exactly. So the manual explicitly directs administrators to configure a support advisor policy specifically to trigger and this is a, quote, standard general webhook alert channel.
Okay, so a webhook is the total opposite of polling.
Right. It is entirely event-driven. ServiceNOW just sits there completely passively.
It's not asking for updates.
Nope. It consumes zero resources for this integration until the exact millisecond that fan fails in Rack 13D.
Wow, okay.
Only then does the SEC actively push an HTTP payload to ServiceNOW.
So it's an inversion of control.
Exactly. From the help desk asking for status to the hardware pushing its own status. And honestly, it is the only way to scale monitoring across modern global infrastructures.
Without inducing, a self-inflicted denial of service attack on your own management network?
Exactly. You just crash your own system trying to monitor it.
Okay, that makes perfect sense from a scaling perspective. The hardware initiates the SOS, but that SOS has to go somewhere. It can't just be, shouted into the digital void.
Right. Somebody have to pick up the phone.
Yeah. We have to build the receiver, and the manual is incredibly prescriptive about how this is done inside ServiceNOW.
Mm-hmm.
You have to configure what ServiceNOW calls a scripted REST API endpoint.
And this is really where we see the transition from hardware management to software-defined service management.
Right.
The Supermicro manual gives exact step-by-step instructions for establishing this endpoint. You navigate to scripted REST APIs and create a new service.
Okay.
And they specify the name as C incident with a space but the system API ID must be syncident with an underscore.
Right, which, might seem trivial to a casual reader, but in ServiceNow's backend, that underscore ID is the immutable database reference.
It's like absolute foundation of the endpoint.
Yeah, but the part of the receiver configuration that stands out to me immediately is the access control list, the ACL.
Oh yeah, the security permissions.
Exactly. The guide mandates setting the default ACLs to scripted REST external default.
Which sounds a bit scary.
Right. If I'm an IT admin, opening up an endpoint with an external default tag basically feels like I'm purposely punching a hole right in my own firewall.
You are punching a hole, but it is a highly, highly calibrated one.
Okay, explain that.
So ServiceNow is inherently a multi-tenant cloud platform, but many enterprise instances are heavily locked down. They're restricted to internal single sign-on networks or, specific corporate VPNs.
So they're sealed off from the public internet.
Exactly. Without that scripted REST external default ACL, any incoming request from the SEC appliance, which sits out on the hardware layer, often on a completely different subnet or even a different geographic data center, it would just hit ServiceNow's perimeter defense and be silently dropped.
It would just bounce right off the outer hull.
Precisely. That ACL setting is the declarative statement to the ServiceNow gateway that says, hey, we actually expect traffic from outside our standard authenticated user pool to hit this specific endpoint.
Okay, so it is the absolute prerequisite for the webhook to even be acknowledged by the system.
Yes, if you don't do that, nothing else matters.
Wow, okay. And once that traffic is allowed to approach the system, it needs a specific address, obviously. The manual maps out the base API path.
Yes, it gets very specific here.
It looks like a PP, followed by a namespace. They use 853615 as an example in the doc, and then incident.
Right.
And within that API, we create the specific resource with the relative path incident. But what I find fascinating here is the namespace requirement. Like, ServiceNow doesn't just let you create a global AP endpoint.
No, they don't, and for a very good reason.
Which is?
The namespace architecture prevents catastrophic database collisions. Because
Wow.
if you have an enterprise running integrations from Supermicro, Cisco, AWS, and like a dozen internal custom apps, allowing global endpoint names would inevitably lead to two different vendors trying to claim the incident path.
Oh, man. Yeah, that would be a nightmare.
Complete chaos. So by forcing the integration into a specific numerical namespace, ServiceNow ensures that the Supermicro webhook logic is totally isolated from, say, your HR onboarding webhook logic.
So we have the path isolated. It's essentially https://yourinstance.service-now.com upon REMA 5, because the full URL, yeah.
And the manual dictates that the HTTP method must be POSed. Now, I know anyone operating at this level of enterprise architecture understands the fundamental difference between DAT and POST methods. But ServiceNow's strict enforcement of this for webhooks is definitely worth dissecting.
It is. It's not just a recommendation. The manual states the SEC sends requests using HTTP POST, period.
Right. So why force it? Why not allow a GAT request just in case?
Because a webhook is, by definition, a state-changing operation.
Okay.
A GAT request is idempotent. You can run a GAT request 10,000 times, and it shouldn't change the state of the database at all. It's just reading data.
Just asking for a copy of what's there.
Exactly. But when SEC fires this alert, it expects a new record to be created, a net new incident ticket, right there in the database.
So it's delivering a payload. It's literally handing a package of data over to be processed, which fundamentally alters the database state. And that is why the REST protocol mandates PAST for this specific action.
Okay, that makes sense.
Because if ServiceNow allowed this endpoint to accept GDT requests, you can theoretically have web crawlers, security scanners, or even misconfigured internal tools accidentally triggering database writes just by pinging the URL.
Oh, just by casually knocking on the door, they accidentally spawn an incident ticket.
Exactly. So by locking it strictly to POSA, ServiceNow enforces the rule that only a client intentionally transmitting a formatted payload can trigger the script.
Right. Which brings us to, honestly, the most critical vulnerability in this entire setup.
The security phase.
Yeah. I mean, think about it. We've carved out a specific isolated URL. We've purposely punched a hole in the firewall using the external default ACL to allow outside traffic.
Yep.
And we've configured it to accept data payloads that will write directly to our IT service database. If you leave that door unguarded, a malicious actor could script a simple loop to send thousands of POST requests a minute to that URL.
It would be devastating. They could just flood the help desk with critical alerts.
Triggering automated pager alerts for every engineer in the company at 3 a.m.
Or they could use it to mask a real attack happening elsewhere.
Hmm.
Or simply overwhelm the database until the entire ServiceNow instance crashes from resource exhaustion.
So we need a bouncer at the door.
A very strict bouncer.
And not just a bouncer checking IDs at the door, but one checking cryptographic signatures before the person even, steps onto the property.
Right. And this is where the 2026 guide gets intensely specific about token authentication.
Yeah, the manual spends a significant portion of its real estate detailing the API key token-based authentication.
And we should clarify, this isn't legacy basic auth where you just pass a simple username and password encoded in base 64.
Right, which would be incredibly reckless for an external webhook sitting on the internet.
Absolutely reckless.
So the manual instructs the administrator to create an inbound authentication profile. You specify the auth parameter type as auth header. And then there is a very strict string you must use for the parameter name. It's CC webhook token, capital S, lowercase cc, hyphen, capital WEBHOOK, hyphen, capital TOKEN.
They are very particular about that string.
Very. So why does Supermicro hardcode this exact custom header string? Why not just use the standard HTTP authorization header like everyone else?
Because using a custom header like CC webhook token prevents collisions with the existing corporate proxy or API gateway authentication schemes.
Oh, interesting.
Yeah, in a complex enterprise network, traffic might pass through a load balancer or a web application firewall, a WAF, long before it ever hits ServiceNow.
Right, you've got layers of security appliances in the way.
Exactly. And those intermediary devices often heavily scrutinize, or they even completely strip out standard authorization headers for security reasons.
Wow, okay, so the standard header might not even survive the journey.
It often doesn't. So by using a custom proprietary header, the token passes transparently through all those network layers directly to the ServiceNow application logic.
That is a phenomenal piece of defensive engineering. It guarantees the knock on the door sounds exactly like Supermicro and nothing else.
Exactly.
So you establish the profile to look for this specific header. Then you generate the REST API key in ServiceNow.
Right.
You tie it to a specific user account. The guide uses system administrator as the example, though in a real deployment, you'd obviously use a dedicated service account, right?
Yes. Always use a service account for this.
And then ServiceNow generates the token.
And the entropy of that token is just massive. The example in the manual is this enormous alphanumeric soup.
Yeah, it's something like now 5NNZ and then just random letters and numbers for miles.
It's an 80-character cryptographically secure string.
80 characters. Okay, so you take this huge string, you attach the authentication profile to the REST API access policy, and you tie that policy directly to our Syncident endpoint.
Yes, that links it all together.
But the crucial architectural detail here, and the manual really points this out, is that ServiceNow validates this token before the script even runs.
Yes, and that distinction right there is the difference between a secure system and a vulnerable one.
Why is the timing so important?
Because when an HTTP POST request hits the ServiceNow gateway, the gateway inspects the headers first. If it doesn't see CT webhook token, or that massive 80-character string is off by even a single digit,
Even one letter. Yeah.
the gateway immediately issues an HTTP 401 unauthorized or a 403 forbidden response and just drops the connection instantly.
The JavaScript logic we write later to actually parse the payload,
Yeah,
it never even wakes up.
exactly the point. It stays asleep.
Ah.
The alternative would be passing the request through the gateway down to the application layer, letting the JavaScript run, and having the script itself check the token.
Right, which sounds fine intuitively, but
But if you do that, you've already allocated memory. You've already consumed CPU cycles on the application node.
I see.
So a dedicated attacker could still take down your instance just by forcing your server to constantly evaluate bad passwords at the application layer.
They just spam you with bad tokens and you choke to death just trying to read them all.
Exactly. So gateway level rejection is literally the only way to survive a flood.
That is brilliant. Okay, so ServiceNow is locked down incredibly tight. We have the URL, we have the custom header requirement, and we have our 80-character cryptographic password.
The receiving end is ready.
Yeah. Now we have to physically map this connection back at the source. We transition into the SuperCloud Composer dashboard itself.
Right. So moving over to the hardware side, the manual guides you to admin, then support advisor, then policies,
Okay.
and you select the standard webhook service alert channel.
And here is where we paste the destination URL and that massive secret token we just generated.
Yep, just copy and paste them in.
The SEC appliance inherently knows to pack that token into the CO webhook token header. That part is hard-coded into their standard webhook service logic.
Supermicro handled that for you.
Right. But looking at the screenshots on page 15 of the manual, there is a toggle in the SEC interface that really caught my eye.
Oh, I know what you're going to bring up.
Yeah. Right next to the secret token field, there is a drop-down for SSL verification, and in the manual's example screenshot, it is explicitly set to disable.
Yeah, that always raises eyebrows for security professionals when they are reviewing these manuals.
It seems like a massive red flag. I mean, we just spent all this time talking about cryptographic tokens and gateway-level rejections, and then the hardware interface just has a giant switch to disable SSL verification.
It looks completely contradictory.
My instinct is that you would never want to send infrastructure alerts without transport layer security verifying the exact identity of the server you're talking to.
And you're right. In a perfect theoretical network architecture, you would never, ever disable it.
So why do they?
Because strict SSL verification forces the SEC appliance to mathematically check the cryptographic certificate of the ServiceNOW endpoint against a trusted root certificate authority. It wants to ensure the connection isn't being spoofed or intercepted.
Which is what you want.
Yes, but this manual is written for the messy realities of enterprise IT.
Which means dealing with legacy firewalls and corporate proxies.
Exactly. In highly secure internal networks, outgoing traffic from the server management subnet is rarely allowed direct, unhindered access to the public internet.
It has to jump through hoops.
It is routed through an internal proxy or a TLS inspecting firewall. These internal devices intercept the traffic, decrypt it to scan for data exfiltration or malware, and then re-encrypt it using the company's own internal certificate before finally sending it on to ServiceNOW.
Oh, wow. So from the perspective of the SuperCloud Composer hardware sitting in the rack, the SSL certificate it sees doesn't belong to service-now.com.
Nope. It belongs to internal corporate-firewall.local.
Which immediately causes strict SSL verification to fail.
Instantly. The SEC drops the connection, assuming it's under a man-in-the-middle attack, when in reality it's just the company's own internal security posture doing its job.
Wow. Okay, so by providing the option to disable strict SSL verification, Supermicro actually allows the webhook to function in these complex TLS inspecting environments.
Exactly. It relies on the internal network's routing rules and the webhook token itself to guarantee authenticity, rather than the TLS certificate.
That is a phenomenal piece of context. The manual doesn't explicitly spell out that proxy scenario.
No.
It just shows the toggle disabled in a screenshot, but understanding the enterprise architecture behind it is absolutely vital.
You really have to read between the lines.
You do. So, okay, we have the URL, the token, and the network path cleared. But in infrastructure engineering, I mean, an untested configuration is really just a theoretical vulnerability.
Oh, absolutely. You have to run the fire drill.
The fire drill, yes. The manual dedicates the next phase purely to testing and validation.
Which is crucial before you walk away and assume it's working.
Right. Inside the SEC dashboard, there is a test service call button. You click it, and the appliance generates a synthetic payload.
Just a dummy alert to test the pipes.
Exactly. And the documentation points you to two distinct places to verify the handshake. First, you check the SEC's own out-of-band management logs, specifically the BMC history page.
And the BMC being the baseboard management controller.
Right, the lowest level of hardware monitoring. The BMC operates totally independently of the server's main CPU and operating system, right?
Yes. Even if the server's OS has completely crashed, blue-screened, whatever, the BMC is still alive, monitoring temperatures and power states.
It's the black box of the server, so the manual shows a log entry there with an alert ID, a trigger severity, and an appliance location, like QA-RAC.13d.
So you confirm it's sent.
Yeah.
And then you verify the reception on the other side.
Right, you log into ServiceNOW, filter the self-service view for incidents, and locate the new record.
And the manual gives us the exact text of a successful test incident.
Yeah, it reads, Unknown SuperCloud Composer Event Alert Test Webhook. You received an Event Alert Test Webhook message successfully.
Notice the severity is unknown.
Because it's just a synthetic ping, it's not a real fire. But the manual brilliantly contrasts this with a real operational alert right after.
Yes, this part is key.
The real incident text reads, Info 52 10.147.173.57 UID indicator was enabled successfully.
And that string of text right there is the entire reason this integration exists. Notice the specific inclusion of the IP address 10.147.173.57.
It completely changes the mean time to resolution, the MTTR.
Drastically.
Because if a help desk technician at 3 a.m. receives a generic alert that just says, a server in QA has a hardware fault, they might spend 20 minutes just tracking down the MAC address or physical rack location of the offending hardware.
Scouring spreadsheets to figure out what's broken.
Exactly. But this webhook delivers the exact IP of the BMC controller directly into the ticket. The engineer can instantly SSH into that specific management interface and begin diagnostics.
It saves precious, precious minutes. But it raises a good question. How does ServiceNow know how to extract that exact IP address from the webhook and format it into that highly readable sentence?
Right, because the gateway validated the token, sure, but it just passed a raw, unstructured block of data to the application layer.
It's just a blob of text at that point.
This is where we dive under the hood. Sections 6 and 7 of the guide are incredible because they don't abstract the software engineering away from the user.
They show you the exact code.
They provide the raw JSON payload structure and the exact JavaScript required to parse it. Let's look at the JSON first.
Okay, let's break it down.
We have key value pairs representing the event state. We see a server object containing system location, QA-rack.21-1.
Very specific.
We see the BMC IP 10.147.163.222. We have an alerted, an event timestamp down to the literal millisecond, an event type like resource updated, the severity mapped to OK, and the event message itself like mellow 0108 UID indicator was disabled successfully.
It's a very clean, structured data model.
Beautifully clean. But the JavaScript provided by the manual to run inside ServiceNow. This is where the real masterclass in enterprise architecture happens.
It really is.
The script starts with a function to process the incoming HTTP request. But before it even attempts to read the JSON payload, it defines helper functions.
Right at the top of the script.
Yeah. The primary one is called SafeStripe.
The inclusion of SafeStripe is a real testament to the fact that the engineers who wrote this guide have suffered through brittle integrations in the past.
Oh, they have definitely felt the pain. I want to break down exactly what this function does because it blew my mind when I realized the implication.
Go for it.
It takes a variable, let's call it v, and a fallback string. The logic is so simple. If v, null v equals undefined, return fallback. Otherwise, convert v to a string.
Just basic JavaScript, yeah.
But why go through the trouble of wrapping every single JSON value in this function? Why not just read the JSON directly?
Because APIs change, networks drop packets, and software has bugs.
Always.
Consider a scenario where Supermicro releases a firmware update for the SEC appliance next year.
Okay.
And due to a minor unforeseen bug in their new release, the JSON payload they send for a specific type of memory failure accidentally omits the severity key entirely.
It just isn't in the payload. The key is just...
Right? It just vanishes. If the ServiceNow JavaScript was written naively, it might just say, hey, read the severity key and append it to the ticket description.
And when the script hits that missing key...
The JavaScript will return an undefined error. And in many script execution environments, an unhandled, undefined error causes a fatal exception.
The whole script crashes.
The script crashes, execution halts immediately, the database write is aborted, and the incident ticket is never created.
Oh my God. So the server is literally melting down in the data center, the webhook fired perfectly, the bouncer at the gateway let it in, but because one single word was missing, the translator had a panic attack and the help desk never got the ticket.
The alert is just lost in the void, and the server melts.
That is terrifying.
But by utilizing SafeStripe, the script acts defensively.
Defensive programming.
Exactly. When it tries to read the severity, it executes var severity, safe speed body.severity, unknown. So if that key is suddenly missing because of a bug, the function catches the null state gracefully. It doesn't crash. It simply inserts the word unknown into the variable.
And the script keeps running. The ticket is still created. The IP address is still logged. A human still gets paged.
Defensive programming, ensuring that the fragility of third-party payloads never breaks your core alerting mechanism.
That is brilliant. It's so simple, but so robust. So, using these safe helper functions, the script extracts the IP, the severity, the ID, and the message.
And then it strings them all together.
It concatenates them into a short desk variable, literally. Foo plus severity, plus alerted, plus alerter, plus BMC IP, plus Serica, plus message.
Which perfectly matches the output we saw in the test phase earlier.
It does, but creating a string in memory isn't the same as creating a ticket in the actual database. For that, the script invokes the ServiceNow API directly.
Right. It uses var and new glide record incident.
Now, what exactly is glide record doing here?
The glide record class is the absolute foundational database interaction mechanism in ServiceNow.
Okay.
By initializing it against the incident table, the script is effectively requesting a blank template of the incident form, bypassing the graphical user interface entirely.
It's just interacting straight with the SQL tables, basically.
Yes. It initializes the form, sets the values, and then there's this fascinating part about the caller.
Oh, yes, it sets the caller id, and it uses a hard-coded alphanumeric string for the user. 681 teen have 35001C5 A33B04 B441.
Yes.
When I read that, I was like, this isn't a username like John Doe. This has to be the internal sysid of a specific system account within the database.
You're exactly right. It maps the ticket directly to an automated service account rather than a human user.
Why is that distinction so important?
Because it is vital for SLA tracking and metric reporting. If you're managing a massive IT department, you want to know exactly how many tickets were machine-generated versus user-reported.
Oh, of course. You want to see the ratio of automated healing versus users complaining about their keyboards.
Exactly. You need that data cleanly segregated.
So the script maps our concatenated string to the short description field. And then it uses an add line array to elegantly format all the raw JSON key value pairs, dumping the entire raw payload into the comments field of the ticket.
Which is such a great touch.
It really is, because it ensures that even if the short description misses a nuance, the IT technician has the exact forensic data the server sent right there in the comments.
Complete transparency for the engineer who actually has to debug the hardware.
And then the critical execution command, var sysID inc.insert.
The commit.
This is the commit. This writes the data to the SQL backend and generates the actual incident number, like INC000012345.
But the script doesn't just terminate there.
Right. It has to close the conversational loop with the SuperCloud Composer.
The final action of the script is to formulate a response back through the open HTTP connection to the hardware.
It sets the response status to 201, and it returns a JSON body indicating a status of success alongside the newly generated SysID and incident number. Now, my background in web protocols immediately highlights that 201 status code. A standard successful web request usually returns a 200 OK.
That's the most common one, yeah.
Why specifically 201?
Because the HTTP protocol is highly semantic. 200 OK simply means, I received and understood your request.
Like an acknowledgement.
Right. But 201 created specifically signals, I received your request, and as a direct result, a new resource was successfully created on the server.
Ah, so it's a confirmation of birth, basically.
Yes. It provides cryptographic certainty to the SEC appliance that the webhook didn't just land in a log file somewhere, but actively generated a tracked entity in the database.
A real ticket was made.
Exactly. If SEC receives a simple 200 instead of a 201, it might actually flag an integration warning, knowing the behavior wasn't exactly as strictly designed.
Whoa. It's an incredibly tight, rigorously engineered loop. Every single layer, the network, the gateway, the parsing logic, the database commit, the semantic response, it all have fail-safes.
It's bulletproof engineering.
But, code this robust inevitably crashes into the messy realities of corporate law.
Oh, always.
Which brings us to the final pages of the guide.
The legal framework wrapping the engineering.
The document closes out with some pretty severe disclaimers. It is copyrighted 2026, Supermicrocomputer, Inc. But the disclaimer of warranty on software and materials is basically a massive wall of capitalized text.
You can't miss it.
It explicitly states that the use of this software, this script, this exact integration we just talked about, is at your sole risk. They make zero warranties regarding correctness, accuracy, or reliability.
None whatsoever. You must assume the entire cost of all necessary service, repair, or correction if it completely fails.
It always makes me laugh a little bit. They hand you this beautifully architected, defensively programmed JavaScript, complete with cryptographic token configurations and safe string parsing, and then legally state, if this doesn't work, we don't know you.
You're on your own.
The limitation of liability explicitly caps their financial exposure to the price paid for the hardware product. Why are hardware companies so aggressive about severing liability for software integrations like this?
Because of the inherent volatility of relying on a third-party API ecosystem.
Meaning ServiceNow?
Yes. Think about it. Supermicro manufactures the physical server racks, They control the firmware on the BMC. They code the SuperCloud Composer software. They have absolute end-to-end sovereignty over that entire hardware stack.
Right. If a fan fails, it's their fan.
But they have absolute zero control over ServiceNow.
Right. ServiceNow is an entirely separate multi-billion-dollar cloud entity.
Exactly. What if ServiceNow updates their platform next year and deprecates the Glide Record API in favor of some brand new database architecture?
Oh.
What if they change how inbound authentication profiles validate custom headers? This entire webhook integration would break overnight and through absolutely no fault of Supermicro's engineering.
The script would just fail.
Yep. Supermicro cannot legally guarantee the uptime of an integration when literally half of the operational equation is governed by a completely different third party.
They provide the map and the vehicle, but they don't pave the roads on the ServiceNow side.
That's a great way to put it.
That context makes the liability cap perfectly rational, honestly. They can only ensure what they physically control. The guide also establishes the governing law as Santa Clara County, California, which is, the heart of Silicon Valley, and provides their global support contacts spanning San Jose, the Netherlands, and Taiwan.
A good reminder that while the webhooks fly at the speed of light, physical hardware still requires global logistics when a motherboard actually fries.
You still need a truck to deliver a new fan.
Exactly.
And there we have it. We have tracked the entire life cycle of an automated SOS. We started with a localized thermal event deep in a data center.
Rack 13D.
We watched the SuperCloud Composer evaluate that event against a support advisor policy. We analyzed the architectural decision to push that data via an event-driven webhook rather than relying on, inefficient polling.
We saw the payload approach the ServiceNow perimeter, where it was scrutinized by a REST API access policy, relying on a custom header and an 80-character cryptographic token just to gain entry.
Bypassing internal proxies through disabled SSL verification when necessary.
Yep.
We watched it get caught by a defensively programmed JavaScript parser utilizing SafeStarter to ensure missing data wouldn't crash the entire instance.
We saw Glide Records spin up a blank form populated with exact IP addresses and raw JSON telemetry, attributed to an automated system account, and committed to the database.
Returning a semantic 201 created status back to the hardware to close the loop.
It's an incredible journey. From the physical failure of a fan to the creation of an actionable incident ticket, the entire sequence executes in a fraction of a second without a single human being in the loop.
It is the bedrock of modern reliability. But before we wrap up today, I want to leave you with a final thought to mull over.
All right.
We've spent this entire deep dive examining how infrastructure automatically reports its own injuries.
Right?
The system gets sick, it bypasses the reception desk, and it perfectly charts its own symptoms into the ServiceNow database. But the current paradigm still relies on a human being reading that ticket to apply the cure.
An IT administrator still has to dispatch a technician, or SSH, into that logged IP address to manually reboot the controller.
Right. But look at the trajectory of automated workflows and LLM-driven logic agents currently being integrated into platforms like ServiceNow.
Oh, I see where you're going with this.
If the hardware can perfectly diagnose itself, outputting perfectly structured JSON with exact fault codes and IP addresses,
Yeah.
how long until an AI agent living inside ServiceNow reads that resource-updated payload, determines the exact CLI command needed to reset the BMC, and fires a reverse webhook back to the SCC appliance to execute the fix?
A completely closed, bidirectional, self-healing loop.
The system gets sick, it writes the ticket, the AI agent reads the ticket, deploys the software cure, verifies the telemetry has returned to normal, and then just closes its own incident report.
Wow.
The patient performs automated, microscopic surgery on itself in milliseconds, while the human IT staff literally sleeps. It's an incredible and honestly inevitable frontier of enterprise computing.
The diagnostic landscape is evolving faster than we can even document it.
It truly is. The next time a massive digital service stays online through a global spike in traffic, just remember the silent cryptographic conversations happening in the background, keeping the physical iron alive. Thanks for joining us on this deep dive.